Alright, it is 6:32, so we're ready to start. So thank you all for coming out on a Thursday night, beautiful Thursday night. I know it is a big commitment to choose tech over the sun. I am Solomon Lederer. I am the founder of Blockmatics, which is we're a blockchain education and training company, and we're also very happy to be Quorum ambassadors. So Quorum has a community ambassador program. So if you want me to be involved in the blockchain community space, or if you have other blockchain company and you want to be affiliated with Quorum, that's something you can easily join. We have a lot of people from the Quorum team here. There's also the Quorum Slack, which is, I believe, open to everyone, which is goquorum.slack.com, something like that. If you go to goquorum.com, you'll find a link to Slack. And yeah, so that's what I'm saying. So we're an education company. We occasionally put on events, but we mostly do training for different companies that want to know about different blockchain technologies. Quorum being one of them. We've done a couple of events previously on Quorum. But we're really excited tonight. We have Libby and Trung from the engineering team of Quorum. They're going to show you how you can actually start, how you can spin up some Quorum nodes. Finally, I just want to give a shout out and a thank you to 2 Sigma Ventures, who are giving us use of the space for tonight. 2 Sigma Ventures, they invest in deep technology, deep tech, sort of like data processing, and which includes AI, blockchain, all that futuristic stuff. So if you want to know more about what 2 Sigma is up to, you can also speak to briefly in the back. All right, without further ado, let me take it over.
All right. Yeah, so I'm Libby, I'm an engineer on the Quorum team. And what I'll do first is I'll just give an overview of Quorum and the different components that are necessary in order to deploy a Quorum network. Is anyone here deploying a Quorum network, or have they deployed a Quorum network? Yeah.
What's the internet situation?
What's the what?
Internet?
Is it internet?
Yeah.
What?
Wi-Fi password?
This is yes. Okay, so this will be helpful then for anyone who's seeking to deploy. And then after I go through those components, and Trung's going to show how we actually can do it on the cloud. So just a quick overview of what Quorum is. Quorum basically consists of these 2 components. One is a fork of Geth, or Go Ethereum, and that's the public Go client for Ethereum. And what Quorum does is adds support for something called a privacy manager, which we'll look at in a second. And the privacy manager helps support private transactions as well as public ones. So you have an EVM state, you have both the public EVM state, but now you also have a private EVM state. And that's the actual state of what's getting executed on the blockchain, right? It's also a permission network, so as in public Ethereum, anyone can join. In a Quorum network, you need to have like a whitelisted set of IPs or node IDs that are allowed to join the network. And there's also pluggable consensus, right? So you have support for instant finality, so consensus such as RAP and Istanbul EBFT, which removes the proof of work constraint, which means that you can get transactions at a much higher throughput. And because it's just a fork of Geth, it supports all these tool areas. So it supports all like the open source tools, Truffle and Mint. Right. So the other part of Quorum is the privacy manager. And this is called Tracera. And the privacy manager is both a transaction manager, which is a component that can accept transactions coming in, and an enclave to store the keys for those transactions. And this is what allows Quorum to support a special private for, and again, we'll go more in detail so we don't get that, it's fine. This private for keyword that will allow for private transactions. And if you do a private transaction, the key there is that the data is only stored on the nodes that are party to that transaction. So unlike in a public network, where all nodes would see all the data, for these private transactions, only those parties to that transaction will see the data. Great. So this is basically what a single node looks like. Oh. It has a Quorum node, go Ethereum. It has a privacy manager, Tessera, and an enclave, and then an IPC connection or an RPC connection between the two. So these parts are always deployed together. So we're looking at this in the context of how do you deploy a network. So this is just setting up these components that we need to wire together, right? So you're always deploying these two things together. Yeah. Okay. So now when we get to, yeah, question?
Does that go be connected to, is that standalone?
This one?
Does that connect to the other one?
This connects right now in this picture just with the privacy manager. We're looking at a single node, and in the next slide, we're going to show what a network looks like. I think that's going to address your question, right? Yeah. So when you actually deploy this in a network, what you have is multiple nodes. So each one of these has both the Go Ethereum fork and the privacy manager. And then you need to set up all the ports, right? So you need to make sure that you have the Quorum port open, or the port that can gossip or spread the transactions around to each other. You need to make sure that the transaction manager port is open and connected, and that's the layer where the private transactions are sent around. Which we'll look at more in a second, see if you can do this. Okay. And then we have the consensus port, and that's another port for the consensus to actually talk to Tom. And there's an IPC connection as well, right? So I didn't draw all these connecting lines for the consensus because it just gets to be a lot of lines, but you can see the basic ports and networks that need to be set up. Yeah? So now we'll look at a public transaction. Like what happens when we send a public transaction to this network? Well, then you need to make sure that you have an additional RPC port opened up on a node that you're going to submit the transaction to. And a public transaction looks exactly the same as a GET or a public Ethereum transaction. So that's pretty nice. So you just send a transaction, you hit your node, it would just be sent along the Quorum ports, and it would get the consensus, would then come to consensus and create a block instantly. Right, so not too much to forget, except for the consensus part. When you go to a private transaction, things look a little different. So for a private transaction, there's sort of two steps to this. In the first step, you would send the transaction, but you'd add an additional keyword, private for. And this private port is going to have the public key of all the parties that you wish to send a transaction to. Right? So in this instance, we're only sending the private transaction to node 2 over here. So we're going to encrypt it with their public key, and we're going to submit this to the GET node, which will then drop down and send it to the privacy manager. That privacy manager will talk to the transaction manager, which will then send it over to node 2 encrypted. And it will send back the hash of the payload, which we'll see in a second step. So far nothing's happened on the public network yet, right? Is that clear? Cool, ended? Okay. And so in the step 2, you get that hash back, and then you're going to submit this transaction to the entire network. So now we're on that sort of overlay of the public network again. And our transaction looks a little different. We now have a payload hash in the data portion, where we had it before, right? And this will go to all the nodes. At that point, each node will check to see if they have a payload that's associated with that hash that is now placed here. And if it does, it'll pull it out and it'll execute that transaction on its private EVM state. Yeah. So again, in public Ethereum, you would just have a public EVM state. But now you have both a public and a private EVM state. And your private EVM state is only on your node. Yeah? Good? Any questions? Please? Okay. So those are the basic components. So this is what we always think of whenever we spin up a network. And it's kind of a lot of stuff to wire up, right? So if you're doing this by yourself, it's kind of like, lots of things going on. So now let's talk about sort of how we deploy Quorum now. We have an example, so Quorum examples, which is on GitHub. And we have a 7 nodes example that you can deploy on Vagrant or VirtualBox. So that will help you get spun up on your machine right away. There's also 7 nodes which you can run if you have the GET client installed on your machine. That will just run it using localhost and set up the ports for you. But these ports are hard-coded, so they're always going to be the same 7 ports. There's a Docker Compose example, and then there's a more robust thing called Quorum Cloud, which Prem is going to go over in detail in a little bit. And then there's coming And we also have this Kubernetes project, which is Quorum on Kubernetes. So we spin it up and run it on Kubernetes. And nobody knows how to say it, so it doesn't matter. And then there's, so what we also do is we have these containers. So again, these two components, they're all on Docker Hub. So we have the Quorum component, the fork of Geth, and Sarah, the privacy manager, and they're both on Docker Hub. So we can use that. We do use it in the Kubernetes project, and we do use it in Docker Compose. So is everyone here familiar with containers? Yeah, kind of. So containers are just ways to basically have a description of what you're running in some sort of very declarative language. Like, I want to run this operating system with this thing installed, and this thing installed, and this thing installed. And then it gives you isolation from namespaces and seeders. It allows you to basically run multiple processes in sort of an isolated manner, which is really good for deploying. But they sort of run one by one. So you use something like Docker Compose to wire them up together, because now we're going to talk about deploying like 7 containers, right? So you have a container for each deployment. So for that, you can just go Docker Compose up, and there'll be a Docker Compose file that's in the examples, and that will spin it up. But again, this is only on your local machine, so you want something a little bit more robust. So Trump is going to show us. It's going to show us how to actually get this thing out and running on Quorum Cloud or Quorum Cloud. Yeah, so that's the intro. And now Trung is going to show us the fun stuff.
Alright, hi everyone. Everyone is doing okay? It sounds good? Enjoy it? I had only one piece, I had 2 pieces ago. Please start the presentation first. So, hi, my name is Chung. I'm one of the core engineer. I'm going to talk about how you spin up the Quorum network on cloud. So first of all, this is my first time talking to Meetup, so I have some background information about me. From core engineer, I'm doing some of the public cloud infrastructure integration at this moment before joining Quorum Cloud. I'm contributor to the Terraform 4. Who knows Terraform? Alright, that's good. So I need some introduction about Terraform before I go on. So I'm a contributor to Terraform 4 and some of the Terraform providers, especially the AWS providers. Born in Vietnam, Hanoi. I did my bachelor degree in India, in Australia, then raised family in Singapore, 10 years, and now I am in the US to fulfill the blockchain dreams. So you can find me in GitHub and a Slack channel in our forum as well, actual. Right, simple. I'll show you a different way to deploy Quorum nodes first. Very brief introduction. I think Libby touched a little bit on that already. Just want to reiterate that, and some demo right away. And see what next about Quorum Cloud. The Quorum Cloud is a very early project that we open source. It's kind of a baby right now, so we need to do a lot of work, and especially contribution from you guys or from the community to make it better. So you all know several examples. So how many of you have played with Quorum examples? All right, that's fair. So I'm going to use some Quorum examples, scripts to verify our Quorum network stuff. And you know that, for example, like provide you a vagrant blocks and a virtual environment that you can run. We also have a local compose that's using the Quorum Docker images to spin up 7 nodes network, using the same 7 node examples, resources. We have Quorum Maker, one of the tools that we are maintaining. This is like a wizard like, so you start the first node and then you start the second node by having some shell script magic and stuff like that. It's pretty useful for understanding how the network growing, when you try to build up a network. And Quorum Cloud, essentially, the idea of Quorum Cloud is really supporting cloud providers. So the idea is you can really spin up Quorum network in multiple cloud providers like AWS, Azure, GCP, but also you can mix up them as well. So you can say some node in here, some node in there, some node in there. That is the power of Terraform, which I'll talk about in a bit later. Of course, initial support is for AWS, because I'm very familiar with AWS. Azure coming soon, and GCP is waiting for your contribution. Alright, so another one is the Kubernetes, pronounce it right. So that is the open source project, which just open source maybe 1 week ago or 2 weeks ago. It's focused on the Kubernetes platform to deploy Quorum network, which is very cool. You should check out all those projects and play around with it. Give us some feedback via our Slack channel, via our Meetup issues, whatever, reach us, and then we talk about it. Now, as I mentioned, right, Quorum Cloud, the idea is to provision the Quorum network in multiple cloud providers. So how do we do that? We use a tool called Terraform. So Terraform is basically a way to manage your infrastructure as a code. So you can describe the infrastructure using Terraform language they call HCL, hash configuration language, and basically you describe how your infrastructure look like. And then via the standard workflow, Terraform init, plan, apply, it can provision infrastructure for you automatically. And the good thing about Terraform is it maintains the states. So Terraform maintains the Terraform view of the world with your infrastructure. And every time you run Terraform plan, it's going to compare the Terraform view of the world to the real world, right? To see what is the difference between that, and then it figure out like what change needs to be done to the target cloud provider. So it's pretty powerful, tools for DevOps and for infrastructure engineering. So in Quorum Cloud, I'm trying to leverage Terraform as much as I can to make sure that we have a single workflow to deploy Quorum network into the multiple cloud providers. For AWS, for Quorum Cloud, right now we are supporting the deployment on AWS Elastic Container Service. Anyone know ECS in AWS? Okay, good, nice. So basically, it's leverage container in AWS. One of the services that I'm using right now is AWS ECS Packet. Is just another container technology that AWS offers to us. We're using the official Quorum images from Dr. Hub to set up the Quorum network. And then we use some S3 bucket to store the states of Terraform and some EC2 instance to make this a jump host to our Quorum network. So before that, let me give you a quick view of how the Quorum Cloud AWS looks like in terms of the architecture. You can see that, right? So that's a little ASCII diagram that I got in Meetup. So you look at over here is the internet coming from here. So there's a public subnet and a private subnet. So private subnet is where we host all the Quorum nodes. So you got like 7 nodes in all in private subnets. None of the nodes got exposed to the public world. Right? And everything is going by the bastion node. So basically it's a jump host. So everything is traffic is going to the bastion host and then goes to the network. So those ECS containers are running on this, and AWS ECS Packet manage that for us. So we don't need to worry about how these things are running. We define what the containers look like, how do we start the container, then Amazon will do that for us. And one of the things about this is you don't have access directly to ECS container. It's a black box, right? So all the logs, streaming, and the accessibility is go by Bastion or by the log watch service, which is AWS service as well. Later on, I'll show you how to monitor the whole network using AWS tooling. Right, so the idea is Quorum network is in private subnet. There's only one Bastion node, is in the public subnet that we can SSH to. We can tunnel link through that to go to the Quorum network. So here is the last piece. The bottom part is over here. Talk more about the how I structure the containers in ECS so that it performs bootstrapping the whole network for us. It's a little bit complicated. I think I can make it simpler, but that is the first version of the whole Quorum Cloud AWS that we're trying to do. So we've got some bootstrap containers. So this each of the things is containers of running and dying, and Quorum run and privacy engine run, which are the two containers of running Quorum and transaction manager. Right, so you know that Quorum, dev, and transaction manager always run in pair. So in this, we have two containers running, they are connected to each other. Any questions so far about this? The whole setup? Right. So this setup is recommended because we don't want to expose the whole Quorum network to the public world. If you don't want to use ECS, hopefully we can write another Terraform configuration or Terraform script to spin up an EC2 instance, for example. That's possible too, but the general idea of how we segment the network so that you can protect your Quorum network in the private subnet concept. Yeah, so Terraform 1.11, so 0.11 is used. In Terraform 12.12, there is major change in the language, so we have not supported yet. So right now it's primarily on 0.11. And I mentioned, right, so Terraform gives you a very standard workflow on how you provision the infrastructure. You need your infrastructure, you plan it, to show you all the things that are going to be modified, going to be added, going to be deleted. You verify the change and you apply it. Apply means apply the change to the real world. And then if you don't want it, you destroy it. So clean up everything that you've been created so far. So it's pretty clean how you're managing the infrastructure from Terraform perspective. Now the whole Terraform scripts or configurations doing bootstrapping for Quorum network is this. Basically, it's exactly what you see in the bringing up the Quorum network from scratch from our documentation. It's exactly the same steps. You create a node key, create some default account, create a data tier, you collect all the IPs because in AWS when you bring up a container you don't know the IP, so you have to wait for the IP to be allocated before you can grab the IP and build up the static nodes.json, which is telling the network that these are the hard-coded nodes that go into form the network. And of course, you're going to create some extra data for the Istanbul consensus if you specify it. So I think the next is, so how, when you're going to use the Quorum Cloud? So I recommend that is only for the test network, right? Not for production, because there are a lot of things on production that we need to take care, not only just bring up, right? Day 0 is like you got nothing. Day 1 is you got the network. Day 2 plus is like maintaining it, add a new node, remove new node. Those things are very complicated, so we're not talking about that in this session. And Quorum Cloud is not meant to do the day 2 plus operations, okay? So if you want to have something like we are using it, like we run the Quorum acceptance test suite every day, right, on Travis. So every day, Travis kick off, go to AWS, spin up the Quorum network, 7 nodes, right, run the whole test suite, right, feedback the result, and destroy it. It's a very clean and efficient way of having a network. And if you want to test something like a long-running network, you want a network running like 600,000 blocks, then you can use that as well. And to debug some kind of memory leak or just watch the block generation or catching out on any error logs inside your get or your network instance, your Quorum node instance. I'll show you some of the visualization of how Quorum Cloud see in AWS as well. Right, some demo type. Now, because it takes around like 3 to 5 minutes to bring the whole network up, so I cheated. I brought that up, and I'll show you quickly the Terraform script I'm using and some of the outputs that Quorum Cloud spit out, so that is useful for you to use the network. Okay. So the first thing is the Terraform script. right? So because not everyone very familiar with Terraform, and I already gave some introduction about Terraform. But what you see over here is the on the left-hand side is the Terraform, they call it configurations. So it's very descriptive. You can see, it's a declarative language that helps you to describe the infrastructure as a code. Right? So for example, this is one of the examples. So data, AWS AMI, this, and then filter. So basically what it does is it's a data source for Terraform. You're going to call the AWS AMI API, pulling back the AMI information, pulse your filter, and make it to be ready to be referenced in anywhere else in your code. So yeah, what I do is I pull out the AMI information from AWS, and then I'm going to wire it up to my Bastion node. So I'm using that as a variable and reference to my Bastion node. Say for example here, resource AWS instance. So resource is the concept that Terraform introduced so that it can manage it. So when you say resource AWS instance, Bastion, it means that Terraform going to monitor, going to keep the state of the AWS instance created by this iteration going forward. So you can see there's some kind of referencing. You can do the variable referencing, making sure that things are properly populated inside resource so that Terraform can manage it for you. Right? So some user data, getting a bunch of things here. One of the things about Terraform is it gives you a very standard workflow, right? Init, plan, apply. How do you feed the information, like input information to your Terraform? It's via something called the variables. So in here, variables.tf containing all the variables that you can declare inside your Terraform configuration, and you can feed it from at runtime. So here I have a bunch of variables like give me the region that you want to deploy the network on, give me the network name, how many nodes that you want to provision, and so on and so forth, right? And these variables are getting populated from a very special file called tf files. So tf file is the standard files that Terraform going to read and then try to populate the variables into the Terraform configuration and run it for us. So here I declare like what are the subnets, private subnets that I want to deploy in my network. Right? So you can provision in different subnets. What is the public subnet for my Bastion node? Right? And what is the side blocks that I allow to access to my Bastion? Right? Because it's got a security group that provides connection to the Bastion node. What consensus mechanism that I want to use, number of nodes that you want to spin off, the Docker image tag that you want to use, like 2.2.4, and the Tessera Docker image tag that you want to use for the code node. So there are a bunch of customization that you can do fit into this script, and then under the hood it's gonna do all the hard working like calling the AWS, provisioning security group, provisioning ECS containers, getting the Bastion up and running, creating all the node keys, and do all kind of heavy lifting for you to make the network be available. Now, let me show you quickly on how it looks like. I recorded it, I cheated. Right? So here is the replay of my running because I'm afraid of the Wi-Fi thing. So the first thing is over here is I'm getting my public IP because I need to know my public IP so that I can get into the Bastion node. There's a security group that I don't want to open to everyone in the world. So that's why this step is required. So I got my public IP here, and then I modify my terraform.tf file, right? And then I got a bunch of information that I showed you earlier. Right? So these are information that I just explained to you. And one of the things that I need to modify is I want to make sure that my access Bastion side block should be my public IP so that I can access to the Bastion node from my local machine. Right. So I change it. Right. I update the TFR files. Right. So now is the fun part. So I got the TFR file, specify what kind of inputs I'm going to put inside the Terraform script. Next thing I do is Terraform init. Right. So Terraform init is initialize the Terraform environment locally to make it ready by downloading a bunch of plugins. They call it providers. So the way Terraform works is it's a plugin-based architecture where they got a Terraform core, and every single Terraform providers is a plugin. And then all the Terraform providers will talk to the API to manage the infrastructure for you. So you download a bunch of providers. You can see that is an AWS provider, there's a Node provider, kind of interesting naming, some random local providers. Basically, it's a way to manage the resource that you described on your Terraform configuration. And then the next thing you do, Terraform plan. Right. So plan is nothing but right now you are in day 0, right? Now you are in day 1, day 0. So you can see that a bunch of things got added. 38 to add, 0 to change, 0 to destroy. So you are in day 1 right now. And this is the planning to tell you exactly what's been changed, what is going to be added in terms of resources. You see that there are a lot of resources that have been created. Just I can't imagine like how do I do that by hand. Like go ahead, click here, go there, click here. That's going to be awful. And after you plan, you do Terraform apply, right? So you need plan, apply. So apply it will read all the Terraform configurations that in my folder and perform a bunch of API calls to AWS in parallel as possible. Because if you imagine your infrastructure is like a network, right? It's a graph. So Terraform is smart enough to figure out like, okay, if I create S3, S3 doesn't relate to the EC2 that I'm going to create, so it's going to spin two API calls and make it in parallel, so it's make it very fast to provision infrastructure. So the output is like this. It's creating some bash node right now. And right, so the last part is try to look at those waits, because it has to wait for the core node to be up, because it takes time for gathering the IPs and configuring stuff as well. So once the node is up, it performs a bunch of things and it outputs something very interesting. So Terraform, after it runs, you can specify what kind of output that you want to print out to the console. Here I print out a bunch of information which is useful, like the Docker information about the Quorum and the privacy engine, a number of Quorum nodes, and the CloudWatch log group. I can see the logs from my network, and the Bastion information so that I can access to my node, right? Now, the next thing is, now you've got a network up and running. I'll show you quickly. What does it look like in AWS? So in AWS is ECS service, and here it is in our own clusters that I provision, and one of the clusters is my network, Quorum network, my network. And it has 7 nodes, 7 services, right? And each of the services got a task. Okay, so you've got 7 tasks. You can view it by browsing through like 7 nodes, which is up over here. Those are 7 tasks, and each of the tasks, you can view what are the containers that it created. You can see that the node key bootstrap and metadata bootstrap is stopped because it's done the bootstrapping job, right? But the Tessera run and Quorum run is actually running now, because that's exactly what we are looking for. A single node, a logical node containing 2 containers. One is Quorum run and Tessera run. Now the thing is that we don't know where it lives, right? Because AWS ECS packets like manage all the EC2 and manage the Docker deployment for us. We don't know where it runs. So how do we get into the logs? So if you click on, say, Quorum run, got information about the entry point and stuff. It's very similar to Docker parameters. And there's a thing called view logs in CloudWatch. You click on here, it has a full logs information about that node based on the verbosity that we put inside our container. So you can search for it. You can search any log events. You can apply some log events rules on this. So that will perform the AWS alert for you. So it's very well integrated with all the AWS services. Okay, now, so far we have the Quorum network on AWS ECS started. Any questions so far before I show you how to connect to it? All right, no question? Oh, cool. So I need to type, but because I have to hold the mic, the mic over here, so I'm gonna cheat again. I'm gonna play the video. Want me to play the video? Is okay. All right. So here, this is my console here, right? You see that is apply complete. That's where I provision. Just now, what I did was in my office, I'm having a different topic IP. But when I go here, I have a different IP. So what I do is I have to obtain the IP, right? And I did my Terraform JavaScript, and then I reapply the Terraform script, right? You can see that is the network already up, but because I want to add one more IP into my Bastion security group, I perform Terraform apply again, and it's smart enough to tell me that you just need to update the Bastion security group without bringing down the whole network and then bring it up again, right? So just change the thing that you need to change, and after it applies successfully, I can access to my network. Okay. So first thing first, this is my Bastion host, right? Now what I'm going to do is I'm going to go to something called itstart. So the Quorum Cloud integrated with itstart by default. So you can view your whole network using the same itstart instance. So you can see over here, I think it's a very long running network. I think I created it last week or something. It's got 600,000 blocks right now. These are the information about the network. It's unhealthy, so some information. This guy looks nice, but it doesn't give a lot of information actually. It looks great, from the display list. And that is my itstart for the Quorum network. Now, if I want to connect to this network, how do I do it? So after the Terraform script runs, you create a Bastion node, right? I will mention to you that we need to have the Bastion node as a jump host to access the network. So the first thing I do is I'm doing the SSH, right? So my SSH command is telling me that I'm using one of the private key. So this private key is actually generated from Terraform script itself. So Terraform script generated for you a private key, and you can use that to access your network. It's possible that you can change the Terraform script so that it accepts your private key instead. But for the easy to do it, I just generate it for me, and then I'm using it to connect to my Bastion node. This is my Bastion node. Right? And here is a Bastion node, so if I want to connect to different node, what I'm doing is I have some shell script magic that's doing it for me. So I can connect to node 1 by typing node 1. I can connect to node 2 by calling node 2. No magic behind the scenes, it's just like a bunch of get attached to the private network, because you are in Bastion node, you can access the private subnet, so it's easy to get attached. Right? All you need to know is the IP and the port, right? So where is it coming from? So when the Quorum network is provisioned, there's a file called Quorum metadata in Bastion node that listing out for you all the nodes, IPs, privacy address, which is for you private for information, third-party URL for the base error, and these things are the configuration for your network. You can use it for a lot of things. Right. Now you're saying, okay, I have to jump into the Bastion and then get to the network, right? It's kind of a little bit troublesome. How do I access it from outside? Right. So easy, quick answer. SSH tunneling, right? So I got some note here, yeah. So what I'm doing is I'm setting up the SSH port forwarding and tunneling to my Bastion, and from there in my local laptop I can access to the private network if I want to. So here I start up the proxy server. Here I need to export the HTTP proxy using the port 5000 to my SSH terminal. Right. And after that, I'm free to go. So I am attached to, first node example. So this is the first node. Remember, these are the private IP. Okay, it's not public IP. because you proceed through your SSH tunnel, you can get into the private network. You get in, and then you can do like load script like normal public transaction, like normal for examples exercise, like setting transactions, public. I don't remember the file name that I have here. Public contracts, right? So you got mine, and you can do everything with that. For private contract, it's a little bit different because in several examples, you use the hard-coded Tessera public key, right? But here you are we generated it, so we need to take like this information, those privacy addresses over here. So I will change it again. The private contract script to use my Node 7 private key in the Quorum network on the AWS, not the hard-coded anymore. You can see here this information is the private key here is now matching with the Node 7 in the Quorum network. And I can get attached into my Node 1 again, and I do the load script for the private contract. Right. Then it's all good. So the private contract is mine. It's good. That is Node 1. So very simple for example exercise. Make sure that I have access to the contract. I get 42. Right, now I'm going to Node 2 because I'm sending transaction from Node 1 to 7, right? I'm going to Node 2, which is this private IP, right? So go to Node 2, and I'm going to have the API ready, right? I'm going to bind my contract API to the address that has been created up here, right? So if I say get, what do I get? 42 or 0? Bam! Because Node 2 is not part into that transaction, right? Just now I sent a transaction from 1 to 7. That's how Quorum works. Alright, so yeah. Alright, so that's how you can access to your private network from outside the network itself. So last thing that I will touch on is the monitoring part of it. So I will show you quickly on how you can view logs. But one of the most important features that happens is the metrics, which is showing you basically the memory usage and CPU usage of the whole network. So here, if I just click everything, you can see that is all information about individual nodes, CPU utilization, and memory utilization levels for the network. So thanks to Quorum Cloud, that integrates everything at once. You don't have to do it manually or anything else. Any question? Thank you. Yeah.
If you lose access to the content, then you lose access to
Yeah. So your SSH private key is very important. Yeah. You have to keep it. Yes.
For like instats and other accessory tooling, are you guys using like Puppet or something for that, or is it like a custom built?
It's Puppet. It's Puppet. Yeah. It's from Puppet. Docker image, official image. So the large node is actually running a Docker daemon, and then it started the Puppet. It starts as a container inside the large itself, and then we have a get Quorum Docker container inside that to run on the get package itself. So I go down the line with everything is containers. Any other question? Alright. Cool. Thank you so much. You have any questions, feel free to grab me on Slack or got any issue, raise it in the GitHub, and we're happy to answer. Thanks.
Thanks, Frank. Really good job. So I'm sure none of you know me. I'm the developer advocacy lead for Quorum, and so my job is really to answer your questions and ensure that you have proper support for Quorum and things like that. My name is Felix, by the way. We have most of our engineering teams that works out of Brooklyn here, so if you want to stick around and ask us questions about Quorum, how it's been used at JP Morgan and anything else, by all means. We're going to be here for a little while, and thanks for coming.